Guys, and welcome to this video on Introduction to Solving Trig Equations. Now to do this we have to have a really good knowledge of our graphs. So hopefully if you're watching this video you have looked at sine curves and you know they take a sinusoidal shape. The maximum point on a basic sine x graph goes up to 1, down to -1, and the period of the graph from where it gets from the start to the finish is 360 degrees. The center, 180, we have 90, and we have 270. Now, I'd also expect you to know the cosine graph, again, is sinusoidal, so it's got that sine in its name. Everything is very similar. The period is still 360, but actually, you can see it's shifted along 90 degrees. At this point, it's gone to here, this point has gone here, this point is now here, to form the cosine curve. So, really similar, just ever so slightly different. So using your knowledge of trig graphs, you should be able to fill these in. So pause the video, have a go, and when you're ready, hit play. So sine of 30, so if we put 30 in here, you actually get a half. So the nature of these graphs is they're symmetrical. So you need to know these are equal. Sine 120, so if we're putting in 120 into here, you can see we're 60 away, so that means that will be the same. 200 is 20 over the 180, so if we go 20 back from 360, you can type this into your calculator. You'll get exactly the same result. Cos 30, so we're putting in cos 30 here, so you can see there's 30 degrees here. So if we follow this along, we know it's going to be 30 degrees the other side of this. That's not true. I can't believe I just said that. It's just the way my graph looked, it was a bit shocking. So it's actually, let's try and undo that awful bit of writing I've just done. It's just because this point is actually over here. So we're going to be looking at that area there. So that's 330. Cos 60. So this time we're going 30 that way. So we're going 30 this way. Okay, so that's going to be 300. So that's something I would have expected you to have done before watching this video. So I'm amazed at how many students don't understand this question, but what do we actually mean by the sine, cosine, and tangent? And I often get lots of strange answers, but never the one I want. But they are ratios. Okay, so when you hear me say which ratio shall I use to solve this problem, you know, when you were doing basic questions like, say, like this, okay, you should be saying which ratio, and this one would be the tangent ratio because you have the opposite and the adjacent. So it's important to understand that. And it's also important to understand where these graphs came from and how they were formed. Just didn't wake up one day knowing how to do them. And it all came from looking at this unit circle. Unit circle meaning there's a height of, well, the radius is 1. So we know the radius is 1. If I just draw a line here, I know that is 1. Now, when I draw these lines from the center that are not on the axes, so any of these points here that I'm showing you with my pen, I'm in control of where I draw it. So that angle would change all of the time. When I draw this radius in with this new angle rather than 0 or 90, I get a vertical distance and I get a horizontal distance. So if we start playing around with our ratios, this being a right angle, if we call this one y, because it's a change in the y direction, and this one x, because it's a change in the x direction, let's start playing around with the ratios. So let's use the sine ratio. So let's look at the sine of that angle. Well, that's the opposite over the hypotenuse. Well, if we apply that to this question, the opposite is y, the hypotenuse is 1, so y is just sine theta. So to find these heights, I just do sine theta, sine of the angle. If I play with the cosine ratio is the adjacent over hypotenuse. You should already know that. So that means the cosine of the angle would be, well, x over 1. So x, the horizontal distance, will always be equal to cos theta. We do the same with the tan ratio. Tan theta is opposite over adjacent. Well, actually, the opposite we've just said is y, but we also know that is sine theta. And adjacent is cos theta. And what we actually have there, this is what we call a trig identity. And we're going to be talking about those in future videos. So let's have a look about actually what that looks like. So on here, I've got a picture of the sine graph. So when I change the angle, you can take your iPad. Thank you for interrupting my video. Right, sorry about that. So as this moves around up to 90 where it is now, you can see it reach that top point. Oh, you can still see it. And then it comes back down. Now, how do I make that full screen? There we go. If this circle got stretched to 2, like a lot of people say, well, why unit circle? Why can't it be a bigger circle? And I appreciate you can't see the full circle there. I've cut it a little bit. But if I stretch the circle to 2, all that would change is the height of this graph. The amplitude of this graph would go up to 2 and down to -2. The shape would still be the same. If we have a look at I've got the tangent one here as well. Remember that was sine theta is opposite over hypotenuse. When we started plotting those values, we got this shape. And just to let you know, this pi here, that's actually 180 degrees, and this would be 360. This is a different angle measure called radians, but it doesn't change the shape of the graph. So you do need to know the shapes of these graphs and where they came from. So, and these ratios that I was talking about, it's useful to know a few off by heart. For example, sine 30, sorry, didn't even write it. Sine 30 is equal to a half, and so is cos 60. That's also equal to a half. And there is some nice little finger tricks you can do, but I can't really show you them in this video. But if you start with those two, you've got plenty of time to learn the others. So this question is pretty rubbish, to be honest, because, and that's what I'm asking here, what is the problem? If I ask you to solve anything, it's to find this unknown variable. If we think about what this looks like, this sine graph goes like this being 1, this being -1. So a half would be here, and we'd be asking you to report back this value, this one. Oh, but hang on, this graph keeps going. So there'll be more values here, there'll be more values here. Oh, but the graph also goes this way, so we'd have another value, and I think you get the gist of it. There's an infinite amount of problems. Sorry, infinite amount of answers. So what we have to do, we have to specify a range which we want you to look between. Okay, so the question will look more like here. So we have this range here saying, I want you to look at x values between an inclusive 0 and 360. So if we go, I'll just draw it again. We're going to look at this one here. So I'm going to draw it down here. So that's 360, 720, -180. So just for half, we're going to get one there, 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 and there. We know this is 30, so using the symmetry, we know that's 150. We know this point's 360, again with the symmetry, there's another 30, so that would be 390. And 720 take away 30 would be 690. So it actually has 4 answers between the range of 0 to 720. But if we go to -180, there aren't actually any other solutions. So this one would be x equals 30, 150, 390, 690. And that's all well and good when the graph is really simple and easy. But we don't really like that system, so we had to make something better, and that is called a cast diagram. So a cast diagram, if we look at all of these graphs between 0 and 90, so I'm just going to highlight 0 and 90 here. All these corresponding y values, they're all positive. So this is a cast diagram. So say 0 to 90, moving in this direction, they're all positive. If we then change to look at between 90 and 180, so here, here, and here, we notice actually only the sine curve is positive. So when we move to 180, oops, still had the lighter on. When we move to 180, only the sine is positive. What happens when we go to 180 to 270? Only the tan is positive in this one. So we say, right, only the tan values are positive here. And if we move to 270 to 360, this time only the cosine values are positive. Cast, that's where it comes from. Okay. Now that is really useful to solve problems without drawing the graphs, and I'll show you why. So let's go back to this problem. So as soon as you see any sort of trig equation, you draw your cast diagram. C-A-S-T, 0, 90, 180, 270, and obviously this is 360. The beauty of this is if it's more than 360 like this one here, it's just going to keep going round. Now, sine of a half, that's the only bit you actually have to use your calculator for, and you know that is 30. So 30 degrees will be in that quadrant, and it doesn't matter where I put this, I just put it so I can see it would be 30. And for symmetry reasons, we also know it will be here, okay? But I'm going to show you how I know that without understanding the symmetry. So what this says here is sine values of x are positive, okay? This is a positive number. So where are sine values of x positive? Well, they're positive here, because they're all positive, and only sine is positive here. So even if I didn't understand the symmetry, I would still put that line there because of the fact that this is where sine values are positive. If this was a negative, these two lines would actually be down here, but I'll show you that in a minute. And we're always going to put this angle here, this acute angle, in both quadrants. So to solve the problem, what I do is I say, right, within this range of 0 to 360, just go around my cast. Oh, look, I've hit it there. So that's 30. And I keep going round, and I get 150. That being 180, 30 less is 150. Now, to answer the other one, well, we've got those two. So I'm going to put 30, put 150. But now we're actually going from 360 up to this point. So that's 390. We just keep going round. So this is 720 here, and this one is 540. Right, so we've got 360, 390, 450. Ah, we've got another one here. Okay, so this is 30 less than 540, so we have 510. And if we go this range between 0, so this is the negative direction, so minus 90, minus 180, you can see we don't actually hit those purple lines, so there's nothing to report. And that should be exactly the same answers as we just had before. I'll just check that. That doesn't sit well with me. Why do I write 690? What an idiot. so that was 720 there, isn't it? So that's 360, that's 540, that's 510. What an idiot. I do apologise. I'm sure you were screaming at the screen. That's definitely wrong. Well done if you were. So let's have a look at another one. So cos theta is equal to minus 3/5. Cos theta is negative. Well, they're all positive there. Sine is positive there, so cos must be negative here. And cos is negative here because they're all positive here and all cosine values are positive here. So that's what it tells me to draw these angles. So using your calculator, you get inverse cos of negative 3/5, and you actually get 126.86, etc. So that means that to get to this point here, that is 100. I'm going to write it down here. So it's 126.9. So I'm not actually interested in that angle. I'm interested in this one here. So that's going to be 53.1. I always want the acute angles. Okay, so the cast diagram is drawn. We're ready to answer any question now for any given range. So we're going between 0 and 540. So here's 0, 180, 360, and 540. So how many times do we hit it? So we hit it there. So that's 126.9. And we go past 180, we get another one. So we add on 53.1, so we get 231.1, and we get to 360. Do we get another hit before we get to 540? Yes, we do. So we've got 540 minus 53.1, and we get 486.9. These are all degrees. Okay. If we go to this next one down here, I'm just going to use the same diagram. So between minus 180, remember we're going in this direction. So that to there would be, this would be minus 180 here, is 53.1 less than that. So that's actually going to be minus 126.9 degrees. And if we go to 180, we get that same one we had earlier, so 126.9. That's it. So we don't have to draw any graphs. Just keep going with this. All right, so here's a slight variation, and you have to get it so it's just the ratio. So sine x is equal to a half. And this is my range we're looking at. So we draw a cast diagram, CAST. Sine values are positive, so they're all positive there, and sine are positive there. Inverse sine of a half is 30. So let's start with the negative direction. So 0 here. Negative, we're going this way. So minus 180, minus 210. And then we come round, we hit this one as well before the minus 360. So 30 less than minus 360 is minus 330. That's very annoying. They're not in the right order. I can rewrite it if I want to, but there's no need really. Right, so we've gone round this way, and we've got two results. So we're going to go around positively now. So this is the positive, that was the negative. So we get 30, and we get, so all the way around here, so we get to 150. And if we continue round from 180, we don't get any more hits. So that's it. I've got one more? Yes, I have. Right. So sometimes we're going to ask you to do a little bit more rearranging to get there. So if I times by tan theta and divide by root 2, I get that. Okay, so it's now the ratio is on its own. Put a switcheroo. You can call it that if you want to. So it's ready to draw. So cast diagram. Have a think. Where are these lines going to go? Well, the tan theta, this is a positive number, so they're all positive there, and tan's positive there. So we're interested in these two angles from the horizontal. So what is the inverse tan of 1 divided by root 2? 35.3 to 1 dp, so 35.3. So we've got to hit, well, we've got to go from minus 180, so let's do that first. So we're going to go in the negative direction. So we do get a hit, okay, so that is this being minus 180. So we've got 35.3 less than that. So that is going to be minus 144.7 degrees. Now, and then we've reached the end. We don't have to go past minus 180. So if we go in the positive direction now, we're going to go all the way to 360. So we're going to get this first one here to be 35.3. And then keep going round, add on 35.3 to 180, because this is also 180 if we go in the positive direction. What's that? That's 215. Keep going round to 360. There are no more stoppages, no more hits along the way. So, how many more have I got? Oh, I've got a couple more, so that's good. Right, so let's do this one as well. So the ratio is on its own. So let's draw the cast diagram. CAST. The tan values are negative, so where is tan negative? They're all positive here. Only sine's positive, so tan must be negative. Tan is positive here, so not there. Cosine's positive, tan is negative. So inverse tan of -1. Oops. And we get -45. And that's, okay, this is why I've included this one. It's a good one because I'm just going to put 45 in here. But you can see it's down here. So it's going to give me a minus angle. And if you think of the tan graph, I'm just going to draw it quickly for you. We typed in -1. Okay, so the closest one to it was that one. So it's always going to give you the calculator the closest value. So that's why it gave me -45. When you might expected me to give me this one, just over 90, but it always give you the closest. But if it's a minus, you just got to recognize it's just going in that negative direction. So you're just going to put the positive value. And we're only interested in this direction because we're going from 0 to 540. So let's go. So we've got this one here. So that's 45 shy. So that must be 135, just being 180. And we've got 45 shy of 360, which is 315. And if we keep going round to 540, which is also at this point here, we've got another 45 shy of that value. So that must be 495. I think you're getting the gist of it now. This one's a tricky one. The cos ratio is not ready. Okay, so that's cos squared theta, and I can divide by 9. But cos squared theta, I'll point this out now. We're going to talk about this more when we do identities. What this actually means is cos theta times cos theta. We write it like that because if we wrote cos theta squared, it looks just like the theta's being squared. So we moved it to make it easy for everyone to understand. So that's actually what it means. So if we want to get cos theta on its own, at the moment it's being squared, a little bit like saying this problem here, how do we get x on its own? Just square root, okay? When you square root, you get a plus and a minus. So this one's interesting because cosine values are positive there and there, but they're negative there and there. So actually, you're going to need all 4 quadrants for this one. What is the inverse cos of a third? You get 70.5. Now, if you typed in inverse cos of minus a third, what do you think would change? Hopefully, you've had a thought to think about that. And this is where cos is positive, but where's cos negative? The first one is there. So it's actually going to give you that result here. But the acute angle would still be 70.5. So once you just find out one, just pop them in, all of them. Okay, so between 0 and 360, you're going to be reporting that angle, that one, this one, and then all the way around as well. So you could write those down. So this is the last thing I wanted to say, is there are times when I don't use the cast diagram. And that is when I get 1s and 0s, just with sine and cosine. It just really confuses me. So I always go back actually to the curve. So if I get sine theta to be 1, obviously that's 90. If I get sine theta to be 0, I'm going to be considering 0, 180, and 360. And if I get cos theta to be -1, that's going to be 180. So whenever I have -1s, 0s, or 1s with sine or cosine, I just go back to these. Because the cast diagram, there's actually no lines to draw. So I find it very frustrating. Hopefully that's made sense to you guys. Best of luck.